Two questions that we are given, we need to consider if they are similar or not. Are the following pairs of triangles similar? Give a reason for your answer. If you are given two similar triangles from the concept of our similarity, if two triangles are similar, let's say I have triangle ABC and another triangle is EFG, all right? Another triangle is maybe triangle EFG, like that. If two triangles are similar, it follows that the ratio of sides is what? Equal. Ratio of what? Of sides is what? Equal. That is proportional throughout. For similar triangles, corresponding sides are what? Proportional. So their ratio is the same, considering the two triangles. In the sense of the two triangles again being similar, it follows that the corresponding angles will be the same, considering the corresponding what? The corresponding angles. Consider the angle that is at A, then the angle that is at E, the angle at B, the angle at F, the angle at C, the angle at G. So that is the concept that you can consider when two triangles are similar. So starting with the first one, here it's a question that are the following pairs of triangles what? Similar. Are they similar? We are given the first triangle from A, which is triangle ABC, all right, and it's right angled at C. The second triangle is right angled at M, so there is a 90 degree, there is a 90 degree there. So if we consider the sides, because they were given the sides of what? The triangles. We cannot state that this angle and this angle is equal by looking into the diagram. So what we can work with is the corresponding sides. Are they proportional? Is the ratio of sides what? Equal. Taking from triangle ABC to this other triangle, all right, we can use corresponding sides. This, our hypotenuse, the one facing 90 degrees, which is AB, over the hypotenuse of the second triangle, which is what? 5, the one that is facing this, which is NM or NL or LN, whatever way that you can put it there. So you're going to obtain 10 for AB and 5 for this one, which is what? Which is 2. Consider the other sides of the two triangles as well and see if you are going to obtain the same value 2, which is what? The ratio of the sides AB to this other side, considering the hypotenuse. So they must be corresponding. From the 90 degree here, we've got the base, which is our BC, and there we've got the base, which is what? Which is MN. So let us consider these two, BC over what? MN of the second triangle. So here we're considering first triangle over what? The second triangle. So BC from the first triangle over what? Over MN from the second triangle. So BC, that is 6 over MN, which is 3. So divide 6 divided by 3, that is what? That is 2. Same ratio, same value. From the 90 degree of C going up, we've got the perpendicular height, all right? So considering that perpendicular height of 8 to the perpendicular height of what? Of 4. Are we going to have the same ratio? So that's we are considering AC over what? LM. First triangle, that's what? That's AC. over the second triangle, that's LM. So that is 8 over what? 8 over 4. And this was going to give us a 2. We have the same ratio throughout. So therefore, the two triangles are what? Are similar. That is the concept. These two triangles are what? They are similar. So here we are asked, are they similar? Are the following? So that's here, yes. The two triangles are what? The two triangles are similar. They are what? They are similar. And the reason here being what? The condition of what? Our sides that is similar because of what? Proportion, same ratio of sides in our case. All right. So that's same ratio of what? Of sides, or ratio of sides what is equal. Erase the cell throughout. Erase the cell. You consider that. So even if you are working with the two, let's say it is from two sides, it follows that the third one follows the same concept. Once you have two corresponding, the third one also corresponds to the same ratio. All right. So that is why you see here on part B, you are just given two sides. It is because the third side will correspond to the same ratio as the other two. If the first two are giving you the same ratio, the third one also is going to be the same ratio. So in our case, we had A, B, C. All right, actually it was not a 90-degree, it was just triangle A, B, C, normal triangle. So what we can work with in this case is the sides. All right, we have got this from our first triangle, the side of 8, which is PQ. All right, corresponding to this side of AB. So those two can what? Correspond to each other. So if we are going to take that ratio of PQ over AB, it was going to be what? 8 over 4, and that is a 2. From the first triangle, we can take this base, which is our QR, over the corresponding 1,5, which is our BC. So that's 3 over what? 1,5, and that was going to give us a 2. So from these two sides that we applied, it follows that even the third one, PR over AC, was going to give us the same ratio. So that is the concept of what? Similar figures as well. So therefore, these two triangles, they are what? They are similar. We are talking about what? Corresponding sides being what? Proportional or same ratio, like we said there. Corresponding, can just write it in this way, corresponding what? Sides proportional. They are what? They are proportional. So therefore, the two triangles are similar. They are similar. So this is the case. When you are not given further information, like given angles, this and that, just take those sides the way they are corresponding, 8 to 4, 3, and 1,5. You can see that it is the same ratio. And make sure that when you are using the ratio, here is the first triangle to the second triangle. So this is first triangle over the second triangle. The value of the first triangle to the one of the second triangle. You use the same. Do not mix up. You end up taking values from second triangle, dividing to the first triangle. Another one from the first triangle, you divide to the second one. No, you use the same concept on your division. If you choose to work with the second triangle to the first one, maintain that throughout. you are still going to have the same ratio from what you have used. So that is the concept of your similar figures, just a matter of revision in this case. Considering this question that we are given, they were asked triangle ABC, it is similar, it is supposed to be another one there, to triangle DEC. Calculate the value of X and Y. If these two triangles are what? Are similar. Remember, from similar figures, we have what? The proportionality of what? The sides, the ratio of sides is the same. If these two triangles are similar. So in our case, guys, you're not going to worry about angles. Say this angle and this one is the same. No. We are already told that these two triangles, they are what? They are similar. So work from the proportionality concept. We do understand that if these two triangles are similar, the ratio of their sides, corresponding sides, will be the same, like this: AB over what? DE. AB over DE. This is the ratio of what? Sides. It must be equal to the one that is following, in this case, from B to C. Here is from what? E to C. So meaning to say BC over what? Over EC. E to C. Same ratio, which is the same even if you were to consider from A to C, from D to C. AC over what? DC. Same ratio throughout. That is the proportionality concept. So since I'm asked to calculate the values, the value of X and the value of Y, I can simply substitute into this ratio because it is the same throughout. So I'm going to form an equation from there. AB represents what? AB is what? Is what you're given. Over DE, from D to E, that is what? That is a 12. And this is equal to BC, from B to C, that is what? That is a 5. Over E to C, from E to C, that is what? That is 15. This is equal to AC, from A to C, that is what? 3 1/3. Over what? DC, from D to C, that is X. You have formed an equation from the ratio of sides corresponding. They are what? It's proportionality concept. That is what you can simply apply. By the equation that we have formulated from this ratio, you can equate if A is equal to B and it is also equal to C. I can equate A and B, that they are equal. I can equate A and C, that they are equal. I can equate B and C, that they are equal, guys. Because these three, they are the same. So since you need to calculate the value of X and the value of Y that we have in our equation, you can see that the second part here, we do not have any unknown value there. So we can equate the ratios with unknown to the one without an unknown value. So from this ratio, it follows that Y over 12 is equal to 5 over 15. This is what we have. Equating these two, they're the same. And at the same time, these two, they are equal. Equating this, the one with an unknown value to the one without an unknown value. So 5 over 15, it is the same as 3 1/3 over what? Over x. So two equations can be formed from that. You can form anything, guys, from that. You cannot equate the first one to the last one, guys, because we have what? Two unknown values there. It's not going to work to equate those two because we have got what? Two unknown. So equate the unknown to the one that is known. Unknown to the one that is known. You are done. So that you can find the value of x and y from there. That is, here is simply going to solve for y. You can solve for y. Yes, guys, it's use of calculators. You can ignore the 5 over 15, or you can reduce. This is same as what? 1 over 3. So thus we can cross multiply. 3 times y is what? Is 3y. And 12 times 1 is 12. So divide by what? By 3. Y is equal to 4. All right. In this case, again, we can reduce. This is 1 over what? Over 3. So I'm going to cross multiply. That is 1 times x, which is x is equal to 3 times what? 3 1/3, where 3 1/3 can be written as what? If you multiply, then add 3 times 3, that is 9, plus 1, that is what? 10 over 3. This is same as 10 over 3. So therefore, x is equal to what? All right, you can just use your calculator, or here you can just cancel. That's a 1. So 1 times 10, that is going to give us what? A 10. So x is equal to 10, y is equal to what? Y is equal to 4 from that concept. So you see, guys, how they ask these questions. In this case, already you're given that. You're told. The two triangles, they are similar. You're already told that. You're not to prove that they are similar, you guys. No. It is to find, to calculate the value of x and y. So just consider that if two triangles are similar, what is that you know? Proportionality concept. So equate the ratio of sides. From that ratio of sides, you form an equation with those unknown values. Then you can find what? Their values, just like that, right? So that is the concept, just a matter of revision from there.